Okay, so here comes our second little lesson on unit conversions. This is Math 052. This and the first one we did are the entirety of section 4.1. Math 038, these two lessons are the entirety of section B4. Math 053, as we were just talking about in class, you have previously learned this, and any question could theoretically ask you to convert units. They can give you centimeters, but it wants the answers in meters or something like that. So the ability to do quick metric conversions definitely can come up. And this actually is specifically in Math 024. So for Math 02 and Math 023. So in Math 023, Unit 4, they introduce the metric units and the prefixes and all the basic idea of all of them. You don't actually have to do any conversions. So kind of like the first half of this video is really suited for you. And in Math 024, Unit 6, you actually do full out metric unit conversions. So this whole video is good for you. Yeah, so let's dive in here. So last time we looked at the imperial system of measurements and converting also, we converted from imperial to imperial units and also between imperial and metric. So imperial to imperial would be like feet and inches. Imperial metric would be inches and centimeters. And we remember that the conversion values on your conversion chart for all of those are all really weird numbers, right? 12 inches in a foot, 3 feet in a yard, 1,760 yards in a mile. It's all over the place. 16 ounces in a cup. And it goes on and on and on. The metric system is instead built entirely around powers of 10. And this makes the unit conversions in metric way, way easier, because when you're multiplying by 10, you're just moving the decimal. If you're multiplying or dividing by 10, you're moving the decimal one direction or the other to make the number 10 times bigger. You don't have to pick up your calculator. You don't have to set up ratios and multiply and divide. You just slide the decimal around. The imperial system just sort of happened over 1,000 years or so. And eventually, people were all using these sorts of measurements and they decided to standardize them. And that's where all the weird conversion factors came from. The metric system, on the other hand, was designed intentionally to be a simpler way to do your measurements. So we're going to do our very first metric conversion using the ratio method from imperial, even though that is not what you want to do, but just so you can see kind of what happens and see that you really are doing the same thing. There's just a big shortcut in these. So we have been told that 1 kilometer is equal to 1,000 meters, and we've been asked to convert 36,152 meters into kilometers. So let's set up our ratio method. On the left side, you remember we put our conversion factor, 1 kilometer to 1,000 meters. And then over here on the right side of the equation, we put the thing we're converting, which, see, 1,000 meters is on the right. So our meters is on the right, 36,152. The kilometers is on the left. So our unknown kilometers we're trying to find is on the left. Turn those into fractions. Do the cross product that doesn't have a variable and divide by the other one. So n is equal to 1. The red one's multiplied, divided by the blue one. And you notice that that 1 on top just obviously doesn't change anything. So really we're just dividing by 1,000 here. You can do it on your calculator if you want. Hopefully you don't have to, because when you divide by 1,000, that's a 1 with 3 zeros. The decimal just moves 3 places to the left, right? So there is a metric conversion done with the style that we are forced to use for imperial conversions. We calculated that 36,152 meters is 36.152 kilometers. But that was a lot of work when you can just see looking at our answer that all we had to do was move the decimal over 3 spots, right? So let's work out a shortcut that takes advantage of this power of 10 business that metric is all built around. So in metric, there is a base unit for each type of measurement. And when I say types of measurement, I'm talking distance, mass, and volume. It could be anything else as well. That you can apply the metric prefixes. You actually do see metric prefixes with your computer memory applied to kilobytes and megabytes and tetrabytes. Those are all metric prefixes put on memory storage, bytes. But we're not going to talk about that. We're just going to focus on distance, mass, and volume. So those are the base units, and you can see here that the base units for distance are meters, the base units for mass are grams, and the base units for volume are liters. And then there are prefixes that indicate how many powers of 10 away from the base you are. So kilo, hecto, deca, deci, centi, milli. These are Latin, derived from Latin words. Kilo is 1,000, hecto is 100, deca is 10, deci is a tenth, like a 10 but smaller, centi is 100th, and milli is 1,000th. So as I said, everything going 10 times at every step. Then we put together the prefix with the base unit. So meters is the base unit. You have 10 meters, you have a decameter. 10 of those is a hectometer. 10 of those is a kilometer, but we say kilometer, don't we? And meanwhile, going down, a tenth of a meter is a decimeter. A tenth of that is a centimeter, and a tenth of a centimeter, as you all know if you look at a ruler, is a millimeter. And then we do the same thing with grams and the same thing with liters, like so. So we have a base unit. It's important you remember that base unit because it actually takes up one step, right? Sometimes people will skip over the base and they'll go straight from deci to deca or vice versa, but that's actually 2 steps on the metric chart. And there I've switched to, so those are the words we use, but in your chart you're probably not going to have the words, you're just going to have meters, grams, and liters. One little common thing I do see is people get confused between meters, the base unit, and millimeters, the 1,000th of the base unit, right? 3 steps on the chart. So if you see meters, they're not talking milli, they are talking the base unit right in the middle there. And in red there, I've put the ones that we really actually commonly use. All the rest of them are technically there. I have never heard anyone talking about a hectometer or a decagram or a I don't know that I've heard kiloliters. I didn't put it on red. I'm trying to think if I've ever heard anyone talking about kiloliters. I don't think so. So those ones in red are the ones we commonly use. Kilometers for measuring long distances, meters for measuring shorter things like the size of rooms, and centimeters and millimeters, of course, for measuring quite a bit smaller things. Kilograms, grams, and milligrams you will see in the store, at the grocery store, and in your medications. And for the volume, we really only use liters for large things like jugs of milk, and milliliters for smaller, lots of canned goods, right, are measured by the milliliter. And we talked about this. Each step down the chart is 10 times smaller. So 1 kilometer is 10 hectometers, right? It takes 10 hectometers to make 1 kilometer, so hectometers are smaller. 10 decameters is 1 hectometer. It takes 10 meters to make 1 decameter. 10 decimeters is a meter. 10 centimeters is a decimeter. And 10 millimeters is a centimeter. Or if we do this a different way, 1 kilometer is 10 hectometers, which means it is 100 decameters. 1,000 meters, that's the one we already saw in our sample question we did at the start there. Kilometer is 1,000 meters. A kilometer is 10,000 decimeters, 100,000 centimeters, and 1,000,000 millimeters. Now I started with kilometers there. I could have started anywhere. So let's say we start with decagram, and I've switched to grams here just to switch it up. 1 decagram is 10 grams, 100 decigrams, 1,000 centigrams, and 10,000 milligrams, getting bigger by 10 every time. And we also want to remember as we go forward that every one of those zeros means we're sliding the decimal left or right 1 more spot when we do our conversions. How do you know when to go left? How do you know when to go right? We'll talk about that very shortly. So this is going to be on your formula sheet. Some courses don't supply this. You're not allowed to have this. You have to memorize those metric conversions in order. But in your courses here, you will have access to this. It's on your formula sheet. And so they've been very intentionally set up going from left to right. And the reason for that is the reason you go on the direction you go on the chart is the same direction that you move the decimal. So easy. So when you go from, I think I have an example. If you're converting from kilometers to centimeters, there you go. You're starting at kilometers in red, and you want to convert into centimeters in blue. So you've been given, how many centimeters is 5 kilometers. For some reason, you want to know that, right? So you're starting with kilometers, you're going to centimeters. That means 5 steps to the right. 1, 2, 3, 4, 5 steps to the right. That means all you got to do is slide the decimal right 5 places. What you're doing is you're technically dividing by 100,000. That's a 1 with 5 zeros, but you don't need to do it that way. You don't need to pick up your calculator, right? You just go 5 to the right. Most common mistake right here. Here's what people accidentally do. So they're going from kilometers to centimeters, and people will count that first one, and they'll go 1, 2, 3, 4, 5, and they get 6 instead of 5. So it is 5. I bolded it here. 5 steps. So starting at kilometers, start to walk. 1 step, 2 steps, 3 steps, 4 steps, 5 steps to the right. I might do another one. Oh yeah, we're going to do some conversions right now. So 21.57 milliliters, we want to convert into centiliters. So let's identify those two. There's milliliters in red and centiliters in blue. So we are going 1 step to the left from the red to the blue. If we're going 1 step to the left, that means we're going to take this decimal and slide it 1 to the left. 1 left on the chart means move the decimal 1 to the left, so that will become 2.157 centiliters. 1.5 kilometers, and we want to convert that into meters. Let's see, there's the kilometers and the meters. From the red to the blue, right? We're starting with kilometers, going to meters. 1 step, 2 steps, 3 steps to the right. So if we took 3 steps to the right, that means very simply we move the decimal 3 to the right. Now watch, we don't have enough numbers to do that, but we know that 1.5, we can add as many zeros as we want. So 1.5 is the same as 1.500. Now go 3 steps to the right. 1, 2, 3. We should get 1,500 meters. 1.5 kilometers is 1,500 meters. 3 steps right means the decimal goes 3 right. And then the final one, we're going from milligrams in red to kilograms in blue. So there on the chart, milligrams in red, kilograms in blue, all the way from one end to the other. 1, 2, 3, 4, 5, 6 steps to the left. So that means we move the decimal 6 to the left. Now there is no decimal, but of course we know that means the decimal is after the last number. So our decimal is right there after the 0. And we're going to go 6 to the left. First 3 are easy. 1, 2, 3. And we're there in front of the 1. Now we're going to go another 3. 1, 2, 3, which means we're going to have to put zeros in to fill those spots. And you notice I didn't bother writing the last 0, 1, 1, 0, because of course we don't need to. That last 0 doesn't change anything. So 110 milligrams is 0.00011 gram. 110 milligrams is 0.00011 kilograms. Right? So metric conversions, there it is in a nutshell. You have this in your formula sheet. If you are sliding to the, if you are moving left on the chart, the decimal goes left. If you're moving right in the chart, the decimal goes right. And that is your metric conversions. Now, we're going to do one more little side topic here. we're going to talk about converting temperature, and as in almost every measurement, the imperial system and the metric system have different ways to measure temperature, and as in everything else, the metric one was very intentionally designed to be as easy as possible, and the imperial one just sort of developed over time and was eventually adopted and doesn't make a heck of a lot of sense when you really think about it. So, both systems are based around the freezing and boiling points of water. So I have a very, very rudimentary thermometer there on the side, that big rectangle. Imagine that's some kind of a container, and that you have, usually it's mercury, although there's other liquids you can put into a thermometer that will do the same job. And the hotter it gets, the more the mercury expands and fills up the container. The colder it gets, the mercury contracts and goes down towards the bottom. That is the basic idea behind how thermometers work. So what they do is then they mark on this container. This is how thermometers were originally built. They put the mercury in the container. They put it in some ice water, which is at the freezing point of water, and then they put a line at where the mercury is. Then they put it in some boiling water, and then the mercury expands and gets bigger, and then once it settles into its new location, they put another line at the boiling point. Now you have the freezing point and the boiling point. For the Celsius measurements, which we're going to do on the right there, they very sensibly decided to call the freezing point 0 and the boiling point 100, like so. And that means that you can then take a little marker all the way down your thermometer and mark in 100 equal pieces, and that each one of those pieces will be 1 degree Celsius. So Celsius, 0 at freezing, 100 at boiling. Break it into 100 equal pieces. Those are degrees Celsius. And then, of course, you can use the same size of markings to continue to go up to much hotter temperatures or down to even colder temperatures, which are going to be in the negatives. So what did they do for Fahrenheit? Well, they made the very obvious choice that the freezing point of water should be called that should be an F right there, 32 degrees Fahrenheit, that should say. Left side is Fahrenheit. I did it for both of them. So both of those C's should be F's on the left. That's an easy fix. So the Fahrenheit people called 32 degrees the freezing point and 212 degrees the boiling point. Where they came up with those numbers, I do not know, but that's the numbers that they chose. And then you can break that into 180 equal pieces, because 32 to 212 is 180, and each one of those pieces is 1 degree Fahrenheit going up. You can see that the Fahrenheit temperatures, you can drop down below 32 but still above 0, and you're in the freezing range, right? Okay, so Celsius and Fahrenheit have their zeros offset by 32, and the size of each degree is different, right? So the freezing point is 0 for Celsius, 32 for Fahrenheit. So 0 Fahrenheit is down here somewhere, 32 away from 0 Celsius. And the easiest way to convert between Fahrenheit and Celsius is actually just to use these two formulas, which are again on your formula sheet. If you have been given the degrees Celsius, use the first formula, plug it in for C, calculate F. If you have been given the degrees Fahrenheit, use the second formula, plug it in for F, find C. This is kind of interesting. If you're curious about where these magic formulas come from, so remember we said they're offset by 32. Well, you can see the 32 in both formulas. And where does this 9/5 come from? Well, 100 degrees Celsius, a change of 100 degrees Celsius is equal to a change of 180 degrees Fahrenheit. You don't have to know this, by the way. This is just interesting. 100, right? 100 from freezing to boiling in Celsius, 180 from freezing to boiling in Fahrenheit. Take that fraction 100 over 180. Reduce it by dividing top and bottom by 10. They're still both even. Divide top and bottom by 2. Look at that. There's that 5/9 in the one formula. or the flip of it, the 9/5 in the other formula. Now you can see in one case, order of operations, you have to multiply first, then add. In the other case, you have to subtract first, then multiply. That is, strictly order of operations. You're going one way or back the other way, from Celsius to Fahrenheit or back from Fahrenheit to Celsius. Okay, so here's a couple examples. We're going to convert. So we've been given 72 degrees Celsius. How much Fahrenheit is that? There's the formula we want to use because we've been given C. And then over here, we've been given F. So here's the formula we want to use to find Celsius. I'm going to plug the 72 in for C, and the rest is just working it out with your calculator. We're going to type in 9 divided by 5 to get that fraction. Then we're going to multiply by 72. And whatever that answer is, we're going to add 32. And you should get 161.6 degrees Fahrenheit. Give that a try in your calculator sometime just to check if you want. So 9 divided by 5 times the 72 plus 32. Over here, we're going to plug in 15 for the Fahrenheit. And here we got to do the subtraction first. So we're going to go 15 minus 32. You're going to press your equals button to get a number there. Then you're going to go times 5 divided by 9, right? Or if you want to work out the bracket first and then multiply by 5/9, by all means, you can take that extra step and write it down. But you can't do it in one step like this, right? 15 minus 32, press the equals button, and then times 5 divided by 9. And you should get negative 9.4 degrees Celsius. Not surprising it's negative because 15 is smaller than 32, so it's smaller than the freezing point of Fahrenheit, which means that we should get a negative number for the Celsius.